G'day there, you're watching the Aussie BIM Guru, and today we're covering a topic in Dynamo for Autodesk Revit, and today we're looking at exporting family types using Dynamo. So thanks to Frank for requesting this topic. He reached out to me by email as well, and went into a bit more detail about looking to find a way to export family type data and re-import it into Revit as well. So for the non-Dynamo based workflow for this, I do have a video on how to update family types purely using Excel and family type files. It's a little bit complicated, but in my opinion, it's about the same amount of time to do this if you don't have the Dynamo script available. So the workflow essentially is to create a two-directional link between our families and Revit via Excel using Dynamo. So essentially we want to be able to export a select number of parameters per family type in a family in Revit. But we also want to be able to add extra types and modify the parameter values of pre-existing types in the family as well. This can be really helpful for families that have a lot of types, such as doors and casework. And I think you'll find this quite a helpful workflow to have up your sleeve. So the output is ideally going to look a little bit like this in Excel. So we'll have a row at the top telling us what the data type is, a row below which is what the parameter name is, and then each row essentially represents a type of that family with the parameter values as we specify them. It's important that we're going to use a user interface because we don't want every single parameter in the family. Some parameters won't be relevant, or they might be okay just to be left blank or at a default value when we create a new type using Revit. So we will have the ability to limit how much we export. So when I say data types, it's really important to understand data types when building this script. So it's hard to work between different data types in Excel and Revit and Dynamo. So things like text, which is strings, integers, numbers, booleans, or yes, no in Revit, and also materials. These parameters are really critical to handle in and out of Dynamo as the right data type. So we're going to have to be really careful when we export our data and import our data to consider what data types have been taken out and returned back. Because unfortunately, Revit can't be given the wrong type of data type to populate a parameter. So I can't use text to populate a number field, for example. Luckily, there's a lot of ways in Dynamo to convert data, which we'll look at in the next part. So you can see here, for example, it's possible to convert a string into a number and also into an integer as well by applying a floor to it. Likewise, you can convert a string into a number here, and also we are converting, I believe, a string into an integer using string from object and string to number nodes. And likewise, we can obviously really quickly process a yes or a no as a string using an equals node into a true or false boolean. So we'll look at that in the next step, but it's important that when we take out our data types, we tell our Excel file what data type to expect, because in the next part, we'll process that data type in order to convert the data back into Revit and Dynamo data from Excel. So we're going to be using data shapes today, but otherwise we're not using any custom nodes to build this script. And ideally, if you can use 2.0.3, great, but I believe it should work in a majority of Dynamo versions. So without further ado, let's jump into our file and actually start extracting our family data. So essentially, I'm in a project at the moment, and I just have a family here with two types in it. So I've got a casework family just with two types, and this casework family has a variety of parameters available. A lot of the parameters are either instance-based or they're locked down with formulas. We're going to be able to ignore the instance-based parameters in this case because they don't really matter for a family type, but we will still have to see the families that are locked down by a formula. So it's good to be aware of which parameters you need to export because we'll be able to narrow down which ones you want to export. So in this case, you can see I'm probably going to want to export my material parameters, my fixed dimension parameters here. I'll also want to export probably number of doors, number of drawers, and my code field. But you can see, for example, my keynote is being pushed by my code field, so all I'll export is my code field. My description, and I believe probably the assembly code as well. So we'll keep those in mind when we export our data type. So we're going to generate our family type list out of the project instead, because we can read the type values of our family in Dynamo. So we're going to start by getting a families dropdown in Dynamo. And I'm just going to find that particular family I want to export the types of. And then we're going to get a family types node. A family types node of a family. So you need to get the family types from this family. So if I run this, I should get two family types. that represent those two types in the family that we've just isolated. So now what we need to do is find all the possible parameters that are within this family. So every family type should have the same parameters available. So we really only need to focus on one type to begin with. So I'm just going to get item at index 0 using a bit of a code block syntax there. And this will just isolate one of my family types. So the first one in the list. We're then going to get all the parameters of that particular type. So we're going to use a parameters node. And we're really just doing this so that we can get the parameter name, because we want to get the name of all the parameters available within this family. Keep in mind at the moment that we're not working with instance parameters because we're dealing with the family type. So at the moment, we'll just get type parameters, which is really important to understand. And obviously, because we're dealing with family types, we don't want to get instance parameters. So we've got a whole list of parameters now, quite a lot of them. Okay. We're also going to get the element parameter values for all the types in the family. So imagine there was maybe 10 types in this family, not just 2. So this will give us a sublist for each particular list. One thing we're going to get rid of from our list of parameters is the parameter category, because we don't really want to export or have the user the ability to export the category of the family, because this is quite an awkward parameter value to deal with. It's not a piece of text, it's actually a category Dynamo parameter. So let's get rid of that. So we're just going to use a equals node to filter. So we're going to check if this is equal to the string category. And we're going to filter out this value, essentially. So we should find those true hits on category. And we're going to just use a filter by Boolean mask. And we need 2. So we're going to mask both of the filters the same way. But one of those masks, we're going to filter the names of the parameters. And the other mask, we're going to apply on a list map basis, because we want to filter each respective family type by that list to remove the element parameters section. Because keep in mind, these element parameters, they're not just the parameter, they're also the value as well. So we're keeping this together for now. You'll see why in a second. So we're going to apply this and we're going to get the out. So essentially it plugs in each sublist here and the output will be the out list. So you can see now that we should just get 2 sublists minus the category field. Okay, so what we're going to do now is we're going to take this particular out list here and we're going to use this to get the parameter values from the family types. So we're going to use a get parameter value by name. And if we map this as well, so we'll take the names of those parameters minus the category, and we're going to again use a list map, and we're going to map that function to all of our family types back at the front. So we're going to get all the parameter values of those parameters. So remember, we filtered out the category parameters, so we shouldn't get the values for category. But there you go. Now you can see we've got 2 sublists, so one representing the values of the parameters of each list. So essentially these are what we'll put into our Excel file. But we're going to have to process a couple of types of parameters. So the first one that we'll notice is materials. So this obviously doesn't really make a lot of sense to the user if we export that. It'll show a very strange representation, 2502, 2504. That's actually the ID of the material. So we're going to need to actually process these into the material's name. So I think we'll do this part first. Actually, first we'll process our booleans first, because it's interesting to note as well that our booleans don't actually show up as true or false. Where are they? Let's go back and just have a look at the values of our parameters. So when we're dealing with the values of our parameters with the parameter included, you note that the booleans are called yes and no. So they actually do represent themselves in a more logical fashion. If I go to index 20 over here, we should find actually index 19 and 18 when those 2 category indexes are taken out. However, we note that we can see 1s and 0s instead, so 1s for trues and 0s for false. But the problem is that we might have numbers for things that aren't booleans as well. So it's really confusing to be able to process these without impacting the other integers that may be maybe actual integers and intent. So what we're going to do is go back and we're going to find a way to process these. So from this list where we've got yes and no intact with category filtered out, we're actually going to go and process this. So we're going to basically take out the parameter name from the front, but we're going to turn this into a string, and this should preserve yes or no. So you can see now that now our booleans are represented by actual yes or no, but we need to get rid of this parameter name off the front. So we're going to find the index of the first semicolon in that string, because essentially that represents the point where the parameter name changes to the parameter value. So we're going to take that string, we'll build a code block, and essentially we're searching for semicolon, and we'll ignore case. So now we should get a list of the first index of a semicolon in each one. And what we want to do now is we want to remove characters up to that index. However, you will note that after the semicolon there's actually a space. So we're going to need to remove a little bit more than just that. So we're going to need to remove that plus 2. So we'll just do a formula x plus 2. And we're removing from start index 0, so the start of the string. So from the start, that index plus 2. And we find now we're just left with our values. However, now we see that our booleans are yes or no. But the problem is that everything here is now text, and that may not be necessarily appropriate. So what I'm going to do instead is just focus on the value of yes and no. So I'm going to build a little code block to process this. So I'm going to say yes check equals to an input string equals to the string yes. So if I feed this string in to this variable, we should get a list of trues or falses that essentially check does the value equal the string yes in each sublist. Likewise, I'm going to build another function using the same variable to check or no. So we're going to say no check. And finally, we're going to use an and condition, an or condition, to check if either yes check or no check are true. So this will basically tell us whether these indices equal yes or no. So now we know we can focus on these particular values. And from here, it's simply a matter of using an if statement in order to interchange the values in this list over here with a yes or a no whenever one of those is a yes or a no. So we're going to check based on our or condition. So if this is true, we're going to replace these values, and we're going to replace them with true. Well, yes check boolean essentially. So when this is yes, it will say true. When this is not yes, it will say false. And this is important because we're still going to be feeding through the indices that don't equal yes, but when we do, they'll say false. When they do, they'll say true. So essentially we're replacing these ones and zeros with a boolean, which is the true and correct object type in this case. So when false, we take the values from our sublist of parameters. So if I run this, we should have a reconstructed list where our ones and our zeros have been replaced with trues and falses when they're booleans. So we successfully processed our first data type, which is a little bit trickier. The last thing we need to process now is our materials. So there's a few ways to do this, but the easiest one is just to check the material name. I'll just double check if this is a custom node. I think it might be. No, okay, it's not a custom node. Good. So we're going to get some warnings on this node because not all these things are materials. So you will get the material name where it's correct at least. So what we're going to do now is double check the object type of all these elements, because we only want to replace these values when it's a material. Otherwise we're going to add a whole bunch of nulls, which we don't want to do. So we're going to check the object type, and this will actually tell you what object type Dynamo calls the type of the element. You can see here we have revit.elements.material. So we're just going to create a string that says that. And we're essentially going to be finding that. So I don't think I can copy and paste that. So we'll just type in revit.elements.material. So we're essentially checking where this is the case. So is this equal to that? And again, as you can probably guess, we're going to use another if condition in order to process this. So you'll see it should detect where our materials occur in our list of values. So again, we're just going to get a if condition, and we'll say if this is a material, get the materials. If this is not a material, get the original list. And this should replace the values with the material names. So there you go, now we've processed those values. So now we're really looking at numbers, text, and booleans. So these are handleable data types to go into Excel. Really important. However, we still have our data types preserved back here as the true and correct data type. Because we're going to need to use these in the next part to tell the data coming in what type of data it should be processed into. Okay, so what we're going to need to do now is we're going to take just the first list of these, because every list is essentially the same. The family types all have the same parameter object types. So we just want the first index. And we're going to get the last index of dot. So we're just going to get string last index. So we want to find the last occurrence of a dot, because as you might have noticed with all these object types, they always have system or Revit, sometimes Revit.element for material, but then dot material. So we just care about that last little string. So we're going to search for, in these strings, dot, and we're going to ignore case. So we'll find the last index in each of those strings. And we're going to add 1 to that index, because we're going to find everything after that character. Okay, now we can see the position of those indices. From there, we need to actually get a string remove characters again. So our strings, in this case, will equal that list from back here. Our start index will be 0. I can actually just put that there. Whoops. So our count is this, and our start index is 0. So now we should get a list of just the type of each of those parameters. So nice and clean. This data is good to go into Excel. Okay. So what we need to do now is we need to build up a list of data for Excel. So essentially we're going to build up our data columns. So we're going to start adding items to front. So at the moment we have a list of 2 rows of data for our family types by parameter. So we're going to add some items to front of this. So the first thing we're going to add to the front is actually from a fair way back. So we're going to add the parameter names. So the parameter names are all the way back here. And I believe that they are here. So we're going to add that list on top of here. So we're going to take all those elements that we took all the way back here. So we're pulling data from a fair way back in our script. On top of that, we're going to also add the data type above that. So that's this row here. So we're going to add this item to that list. So essentially we should end up with 4 sublists at this point. So we have our data types, we have our parameter names, and then our types. So as more types are added to this family, obviously more rows will come on the end. Okay. So essentially we have our Excel data at this point. So with this data, we can transpose it to turn it into little subgroups or into columns essentially. So each of these will represent a column in Excel. So data type, parameter name, and then the two parameters for those respective types. Okay, so we're going to need to actually remove one index from this list. So one thing I want to do is always make it so type name is my first column, regardless of whether the user picks it or not. So what we're going to do is actually find the index of that. So we're going to get index of, and we're going to find the index of the parameter type name. in that list. So we're going to go all the way back again to these parameter names. And we'll find out where that occurs in that list. So we can now see that type name occurs at index 46. And if I go into my list here and I go to index 46, as you'll expect, here's my type name parameter. So we're going to we're basically going to get rid of that before we process into our user interface. So we're going to remove item at index, and from that list of transposed lists, we're going to remove that type name, and then we're left with our base data. But what we're going to do is actually get item at index as well. So from that transposed list, we're going to move this data over the top of our user interface so that we can add it on the end. So we're going to just move this over here so that later on we can tack this onto our results that go into Excel so that we can preserve this. Okay, so what we need to do now is actually start building our user interface, I believe. So we've transposed this data. This is what's going to get fed through the UI. So I'm just going to get a list view. And list views, it's important in list views to understand that we have what's called keys and values. So the keys are what you see, the values are what get pushed through in the background. So in the background, we're pushing through these sublists. In the foreground, we need to push through our parameter names instead. So we're going to get another remove item at index, and we're going to remove the index of type name from our list of parameter names. So essentially, we need to go back another step and go pull on that list of parameter names again. So this is quite a popular point for the script to call on. Okay, so we should have keys and values. So these are going to be our keys. So the user essentially says, which parameters do I want to pull out to go into Excel? And then the values in the background push through the sublist to be written as columns. Okay. Feel free to leave comments if that's confusing. This part of the script's a little bit complicated. So we're going to give a name to this button and just say which parameters. So which parameters are we exporting? And I'll just add a little bit of information. So we'll say the height is 500, and we will sort items so that we sort alphabetically. Optional height and sort items. We also need a file path in our user interface as well. So we're going to do a UI file path. And we'll let the user pick where their Excel file is located. So we'll just say the input name is where is your file. Specify a path. That's what the button will say. And there'll be no default path. You can build a default path to a user's desktop if you want, but of course there'll be no Excel file there, so there's not much point. If anyone's used data shapes before, they'll know that you need to create a list for your inputs. So we're going to add those together into a list, and then we're going to create our main interface using the multiple input ++. So this will be our inputs. We'll add a toggle to trigger our user interface. So this is just basically our way of saying we do want to run the UI. And then we'll create a little code block here, and we'll just call this export family types. That's the title of our UI. We'll make a button called export, which is our run button. We'll make a cancel button called cancel. And we'll just say that our maximum height is 1000 and our width is 600. Okay, so we've got our name, our run button, our cancel button, our height, and our width. Okay, so what I might do at that point is just run my UI just so you can see how the multiple input ++ form works. So I'll just save and run. I might just cross check. There we go. So I just need to refresh my UI. So there you go. So we can see our parameter values have come through. So let's just pick a few of these. So we'll just take code, width, depth, height, and let's just say material for panels and glass, and that'll do for now. And we'll specify a path to our file. So I'll just create a new Excel file, and I'll just save this to a demo folder just on my desktop. And I'll just call this demo. Okay, so we'll point to this file and we'll say export. Obviously it hasn't exported to Excel because our user interface hasn't got to that point yet. But essentially now you can see our columns coming through for each of those respective parameters as our first list or sublist. And our second sublist is our Excel file path. So now we can feed this into an Excel writing function at the end. So we're going to use a little bit of code block and add to front transposing. So I'll show you how we do that. So we're going to take, firstly, our second item, which is our Excel file path. We're going to take the name of the sheet that we're going to run a write to, which is sheet 1. We'll just take the start row and column index of 0. We'll take our data to write, and we will overwrite our Excel file. So we're just creating a little bunch of commands there to feed through to our final node, which is, as you can guess, an export Excel. But what we do need to do is add that typed column to the front of our outputs as well. So we're going to do an add item to front. And to our data, we're going to go and append this little sublist of the family type values as a new column. And we're going to write by row. So we're going to transpose our data as well, so that our columns and our rows flip. So that's our data. And then we just feed through the rest of our values. So our file path, which is the second input, our sheet name, start row, start column, and override as true. So essentially that's our script built at this point. This should essentially build an Excel file. I'll just run a quick test. So we'll open up demo script again, just to refresh our user interface. I'll go and pick the right family, which I have, and I'll run. And there's our UI. So let's pick our parameters that we wanted. So we'll do data code, assembly code, description, fixed depth, width, and height, general group, material, glass, and panels, number of doors, not number of drawers, because that's always 0. We'll do yes or no for whether it's a glazed door, for the cabinetry. We don't need keynote because it's connected to the code field. And essentially that's it. And you can see that type name isn't available now because it's going to come through regardless. We'll specify the path to our Excel file as well, and we'll export. Interesting. I'll just cross check. Looks like it didn't export. Wonder why. Our list didn't like being transposed. So we probably need to double check why our data didn't transpose. Okay. So it looks like we had this the wrong way around. So our item and our lists were the wrong way around. So we may just be able to hold the values in our UI that we still have and just rerun this. Yeah, we do. There we go. So that's what will happen if you just make sure you add the item rather than the list like I did there. So just to confirm that, so you'll need the item to be that sublist of type name and the list to be your output from the UI. But essentially this is what you should get. So let's just make this column a little bit wider, say 30, and we'll just make all of these 15 in width. And what I like to do with these is just rotate the orientation of the parameters and just send through all the data. So essentially what we've got now is we have the data types up the top. You can see we have integers, doubles, strings, booleans, and materials. We have the parameter names, and we also have the types by row. And then we have the respective values of each of those. So really powerful data available to us. And obviously we're going to push this back in using Dynamo back to Revit by adding new rows as types, and also some edited fields that we can change in Excel here. So that's pretty much how the script works. Of course, if you want to make this a Dynamo player compatible script, all you will need to do is come back to the start and right click on the families node and just make that an input. And just say which family to export. And essentially that should behave like a Dynamo player script from there. So we could just probably do a quick test and show you that in action. So I'll just boot up Dynamo player. But essentially it should run pretty much the same as it just did then. You could look into the Bumblebee package for more enhanced Excel writing if you want to maintain formatting and text orientation And maybe you want to grey out the rows of existing types so the user more evidently can tell the difference between new and existing. But I guess for me, this works for now. Don't want to overcomplicate it. Okay, so if I just go to my inputs for my demo script, we should just see that single row of letting us pick our family type from the project. So maybe let's test it with another family in the project. I'll see if there's any that are suitable for this particular task. There may not be, because this family is quite good because it has a lot of parameters to pick from. Whereas I'm in an empty template, so I don't think many families would be very suitable in this style of template. No, so they're not really suitable. But we'll just rerun the same. Then we'll rerun it, and this should boot up our user interface again. And obviously we can pick a lot of different parameters. I'll just pick a few in this case. Specify my file path, demo, export, and there we go. Done. So really easy. The only reason I say Bumblebee might be good is because obviously you have to change your column width and your orientation of text every time, whereas Bumblebee lets you retain formatting. But that's pretty much it. So hopefully you'll tune into the next part where we push our data back the other way. So on the next video, we'll be looking at the other direction, where we will take our data and instead take it back into our family via Dynamo. So thanks for watching today. If you've got any comments or feedback on that workflow, please let me know. Hopefully you find this helpful in your day-to-day family editing and type creation. If you're not already following and subscribing, feel free to do so. And hopefully I'll see you in the second part where we do data the other way. So thanks for watching. Take care. Bye.